Hey guys. Alright, so for those of you guys that missed class on Tuesday I demoed the parallel circuit. In order to find the information that you need for the parallel circuit, again, same place, so go to Electrical Fundamentals, go to Circuit. You can click on Parallel Circuit, just so you guys know that it's there. These are some examples that you guys can try, but again, you need that student handout sheet. Okay, so click there, download that. If you haven't already done so, you should have by now. Open it up. And the first thing we need to look at before we start the circuit is the rules. Go ahead and enable editing here, and then I'm going to zoom in for you guys so you guys can see this really well. Okay, so there it is. Okay. So a parallel circuit is a little more funky compared to the series circuit in that you have to do this kind of funky little reciprocal equation to figure out total resistance. But let's look at the first rule. The first rule is voltage is constant. So this parallel circuit is almost opposite of the series circuit. If you remember, voltage is the one that drops across the resistor, okay? And it was current that was constant. In a parallel circuit, voltage is constant. So once you know voltage, voltage stays the same all the way through that circuit. Okay? The sum of all branches, current, equals total current. So the current is the one that's going to be dropping across those resistors. We're going to add those up, and they should equal the total current. And then total resistance is this funky little reciprocal where we got to take 1 divided by our first, 1 divided by our second resistor, and 1 divided by our third resistor, and then we have to divide 1 divided by that total to get our total resistance. So a couple more steps there in order to do that, but the math is still pretty simple, okay? All right, so let's go take a look. So again, for those of you guys that need to test, retest, whatever the case may be, all you need to do is watch my video, show me that you worked through the math, show your work. Once you guys have done that, show me in class, and I will give you either a separate exam or I will give you the original, okay? All right, so let's go ahead and get started. So per that rule, it says voltage is constant. So what's our total voltage? 12 volts. So we can go ahead and write our 12 volts here and then 12 volts all the way through the circuit because it is constant. How do we know? Tells us right there, voltage is constant, okay? So let's go ahead and do that. Again, using the pi. Oops, sorry about that. Some technical difficulties. Okay, and let's go ahead and put our 12 volts in for our total current, or total voltage, my bad. Okay, so now we can go ahead and we can put that in all the way around. Okay, why? Because it's constant. Okay. Looks like I got a little lag here. Okay, boom, 12 volts. Okay. But our total voltage requires a little bit of funky math here, right? Okay, so I'm going to go ahead and set that up, and this is what that looks like. So if I follow this equation, there we go. The setup looks like this. Okay, so it is R, 1 divided by RT equals, and then we're going to go ahead and do that. That is 1 divided by 25 plus 1 divided by 35, and then 1 divided by 45. Okay, boom, there we go. So now let's go ahead and go to our calculator and we'll start doing this math, okay? All right, so we'll go ahead and clear this out. I'm going to go ahead and clear my history as well. And let's do it. 1 divided by 25 equals 0.04. Okay, so we'll go back to our whiteboard and we'll type that in. 0.04. There is some real bad lag on this thing, isn't there? Okay, let me zoom out here. Move this one up a little bit if I can. Oh, no, what the heck? Oh, I used the artboard up. There we go. Alright, sorry about that, guys. There's some definite lag. Okay, so then the next one is 1 divided by 35. Clear that. 1 divided by 35 equals, what the heck? Equals, all right, so that we're going to call that 0.029. All right, we're going to round this digit up since that's 5. We're going to call that 0.029. Okay, so point, just kidding. Try that again. Oh, this is ridiculous. Point. Actually, I think that was 0.29. Is that right? Yep, 0.29. (0.29) plus, and then we'll do 1 divided by 45. All right, clear that. That's 1 divided by 45 equals 0.022222. So we're just going to go 3 digits. So that's going to be 0.022. Okay, well, now we got to add them all up, right? Add this plus this plus this. So let's go ahead and do that. So that's 0.04 plus 0.029 plus 0.022 equals 0.091. But then we got to take that divided by 1. Okay, so we can go ahead and say that is, now we got to do 1 divided by 0.091 equals. Why? Well, because we are doing a reciprocal of. Okay, this is what we're solving for. Okay, so 1 divided by 0.019. 1 divided by 0.091 equals 10.98. We're just going to round that up to 11. Okay. All right. So we got our total resistance. We just calculated total resistance. And now we can calculate total current. How do we do that? Well, close or cross out the I. What are you left with? V divided by R. So 12 divided by 11 equals. Okay, that's what we're doing. So 12 divided by 11 equals 1.09. So 1.09. Okay. But now we got to calculate the current drop across here, okay? And once we do that, then we're going to add them up, and they should equal 1.09. This is how we prove we are correct, okay? So what we're going to do then is we know our voltage, we know our resistor, so we're just going to do that math, and that math is 12 divided by 25 for resistor 1 right there. 12 divided by 35 for resistor 2, and then 12 divided by 45 for resistor 3. Okay, so let's go ahead and do that. 12 divided by 25 equals 0.48. Okay, so we can go ahead and put that in there. 0.48. So we got the current for resistor 1. 1 divided by 35. We're going to call that 0.029. We're going to round that 8 up. Okay, so that's going to be 0.029. And then we're going to do this last one, which is 12 divided by 45 equals. And we're going to call that 0.267. 267. Okay. Yeah. Okay, so that one's going to be 0.27. Sorry about it, not 67, 0.27. And I think that's supposed to be 0.29, not 0.29. Did I screw that up? I think I did. Let's do that math. 12 divided by 35 equals 0.34. Sorry, I really jacked that one up, didn't I? What was I doing? If you guys are like, wait, what did he do? Yep, that was wrong. My bad. That is 0.34. Okay. Now, all we need to do now is add this, plus that, and that should equal 1.09. That tells us if we're correct. Okay, so let's go ahead and do that. So that is what was the first one? 48. Okay. So 0.48 plus 0.34 plus 0.27 equals, yep, 1.09. So that means we are correct. Okay. And everything works. Okay, that's how we do a parallel circuit. I'm going to scroll down here. Bring this one up. Okay. And so this is a good practice one right here, guys. So let's look at this. So you know you got 9 volts going in. So again, you guys are using that same chart. Okay, V. Okay, what's our total voltage? 9 volts. Okay. And then I forgot to write in the V1 here, guys, so you guys can go ahead and do that. All right, so V1 and I1, V2, I2, and then V3 and I3. Okay, but we got to do the same thing for this, guys. So, well, we know 9 volts goes in, so this is 9, that's 9, and that's 9, right? Then we got to do that crazy equation, right? And that one is equals R1 plus R2 plus R3, right? So then that's 1 divided by 80 plus 1 divided by 100 plus 1 divided by 120. Okay? You're going to get decimals. You guys got to add those up. And then you got to take that, whatever you get, and you got to take 1 divided by whatever you get. That'll give you total resistance. Once you got total resistance, then it's just the V divided by R to get current. Then you're ready to go back and start figuring out what the individual current is for each one. Okay? And that's just going to be 9 divided by 80 will give you total. It's going to be 9 divided by 100 will give you total. And then that's going to be 9 divided by 120. And that will give you the third current right there. Okay? All right, guys. Good luck.